Greetings, Professor. My name is Evan, and together with my teammates Darius, Patrick, Minnie, and Mary, we'll be presenting to you our C Group project. So firstly, for our file organization, we have one main folder called C Group Project, and under that we have four subfolders and one README file. Our compiled program will be stored in the build folder, our database file will be stored in the data folder, our header file will be stored in the include folder, and our two main C files will be stored in the source folder. So how user commands are being processed? If we were to take a look at the diagram on the right-hand side, the program starts and immediately enters the main loop, which will run continuously. Within the loop, the program will prompt the users for a command, and then it will pass the input through three main helpers in sequence. The first being readline to safely read the text, followed by upper in place to make the user input uppercase, and lastly the pass command helper to translate everything into a command type. So based on the result, the program will either exit the loop if the command is exit, print an error if the command is an unknown, or use a switch to run the correct handler, such as the open command or the show all command. So after handling these commands, it will go back to the main loop and wait for the next input until the user finally chooses to exit the program. For key data structure, the student data structure stores ID, name, program, mark, and the student's grade. The name and program, as we can see from the image on the right-hand side, are actually character arrays and are fixed size strings. So we use arrays here because both the student's name and program code come from the user input or from the file, and so it's important that we actually create space for it to store the text and not just the pointer. This will help to make our input handling much simpler and also help to prevent issues like buffer overflow, while still giving us enough room to use typical naming conventions and program codes. So for key storage arrays, all the student records are kept in a global array called records, which can hold up to 100 students set by max records. Together with an integer record count, as we can see from the bottom, it tracks how many slots are currently being used. So now I'll be passing my time on to Patrick and Darius, who will be giving us the project demonstration.
Good afternoon, Professor. My name is Darius, and now I'll be presenting my group's C project locally. To start things off, you can just copy-paste the command in the readme.md to get the application running. Afterwards, you can run the build command so that you can actually start the application. And once you've seen this message, you know that the application has been started up successfully. So what you can do now is type in help, and you can see all the commands that our group has done, namely the 7 core functions: open, show all, query, update, insert, delete, as well as save. For the other enhancement features and unique features, my groupmate Patrick will be presenting them in a segment later on. I'll just be covering the core functions and some validation cases for them due to the time constraint. So first things off, let's start with open. And the example that I'm going to use is the simple CMS file in Excite. So what you need to do is copy as path and paste it into the terminal. And if it's successful, it will tell you database open with X amount of records. So what you can do now is do show all to see the data inside. And as you can see right here, Joshua's, Isaac, and John data is inside the text file. So now we will do query to, let's say, find out more about Joshua's data. I'll enter in his ID. And as you can see here, the record is being found with his name, program, etc., all being displayed right here. So let's say I want to update his data. And I'll enter in his ID once more. Let's say if I want to keep his name, I can just press the enter button. But if not, I can just enter the new name right here. So let's say I want to remove his surname and make it all caps. I'll type Joshua, change the program to AI. Let's just change it to 100 so we can see the grade update in real time. And it will tell me record update successfully. So we can do show to check again. And as you can see right here, it's being updated successfully based on what we have typed. So after update, I will do delete. Sorry, I'll do insert. So let me insert a random student data in. And if it's successful, it will tell me once again, record inserted successfully. We can do show to check everything's in place, and you can see right here it's being displayed in the last row. So after that, I'll do delete. And let's say I want to delete Isaac's data away. I'll enter in his ID. All his data will be shown right here. And then if the user really wants to delete it, he can type Y for yes, and afterwards you'll tell them record deleted. Okay, show once again the check, and only these 3 records are left. So let's say I want to save this to the text file right now. I'll type in save, and it will tell me the database file blah 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 is successfully saved. So to check it, we can go to the file explorer and refresh it. And you can see right here, the 3 records being displayed here is the same one as you see in the one in our terminal. So I'll just do some simple validation cases. So let's say insert, if they enter in empty student ID, it will probably have an error message. Same for the other fields, mark, program, etc. So what if they enter something that is not 7 digits? It will tell them, oh sorry. Let's say they enter in 1, 2, 3. It will tell them, oh, invalid length, and it cannot start with 0 and it must be 7 digits. So same goes for other fields. If they enter in a blank name or a name with a number behind, it will tell them, oh, only letter spaces allowed. And then for the programs, they have to follow these 5 as indicated right here. If you type anything else, an error message will be prompted up. You'll tell them use these 5 and the field cannot be empty. And as for the mark, they have to follow the range, which is 1 to 100. And then if they don't, an error message will be popped up telling them that, oh, it cannot be empty, plus it must be between 1 to 100. So let's try 1, 1, for example. And then you tell them, oh, invalid mark must be between 1 and 100. As for the other validation cases, my group mates, Minnie and Mary, will be presenting them due to the time constraint on the whole group end. So this is it for our this is it for my part for the demonstration of the cell call function as well as some validation cases for them. Thank you.
So hi all, now I'll be showing the additional features. So firstly, you can see that Enter help to see all commands at the startup page. So after pressing help, you can see all the available commands. So this is the first additional feature that I have. As well as you can see that show all, which display all student records with a helping saying that optional sort syntax, show all sort by field and order. So field by default, there's 5 elements, ID, name, program, mark, as well as a new additional feature with a grade column, and order ascending or descending. So you can see show all sort by grade. So by default, it will be from A to C. So show all sort by grade ascending will be C to A, as well as show all sort by mark. Sort by mark. From the least to the most. So all sort by mark. Descending from the most to the least. And some additional features such as summary, show summary of records. There is an advanced summary page with a grade distribution of grading students and a static graph shown here, as well as export function. So like I say, entering export data file, data CSV successfully exported. See that the CSV file is right here.
All right, thank you. So now I'm going to be presenting the open file operation logic. So I have taken a snippet from the function code and pasted it on the right-hand side. And so for the open command, the goal is to load a database file of student records into memory. So the function will first clean the file path and try to open it. If it fails, it will stop the function early. So after this, if everything goes okay, it skips the header until it reaches the line that starts with ID. So after this, it reads each line that contains a valid student entry, and each line of record will be passed into a temporary student structure using scanf. Once the fields are extracted, we can expand the program code to its full name and compute the grade. So finally, we will store the completed student into the records array and increase the record count by 1. So overall, this open function actually just takes in raw text from the database file, and it converts it into a proper student structure and loads everything into the in-memory database. For the save file operation, for the save command, the idea is simply to just write the current in-memory data back into a file. So the function first validates the path, it cleans it, and tries to open the file in write mode. If opening of the file fails, it will return an error and exit the function. It will then write a header line if everything goes well, followed by a loop that goes through all the student records Each student is then printed out in a clean tab-separated format: ID, name, program, and marks. This matches the exact format that the open command expects, so the file is fully reusable. At the end, it closes the file and reports success. So the save function, or rather the save operation, is essentially exporting whatever is currently stored in the records array into a consistent readable text file. So now I'm going to be passing my time on to Minnie.
Thanks, Evan. I'll go over the validation used in the 3 critical data management functions, starting with the insert operation. It is important because the program stops immediately if any check fails, so the order of our checks matters. First, we validate the ID. It must be numeric, exactly 7 digits long, and unique, which we confirm by scanning all existing records. Next, we validate the other fields. The name must contain only letters and spaces. The program must match one of the accepted options like CS or EE. Finally, we validate the mark, which must be numeric and fall within the 1 to 100 range. This flow ensures that only clean and reliable data is stored. Next is the query operation. Its validation is key to preventing runtime errors. We perform 2 main checks. First, the input check. It immediately filters out invalid or empty IDs that aren't numeric. Then the main validation step is confirming that the record actually exists. If the search loop finishes without finding a match, the function returns -1 and notifies the user. This prevents later operations like update from trying to modify a record that doesn't exist. Finally, the update operation, which needs more specific validation since it changes existing data. We start by confirming that the record exists. If it does, we revalidate any field the user wants to update. For example, the mark still has to be between 1 and 100. Then comes the key consistency step. Once the mark is accepted, we automatically recalculate the grade by calling the getGrade function. This keeps the entire record accurate and consistent. I'll now hand it over to Meri, who will cover the validation for the show all and delete operations.
Thank you, Minnie. For the show all operation, the first thing the program does is check whether the database is empty. If there are no records, it stops immediately and tells the user that there's nothing to display. If the user includes sorting, for example, show all sort by ID ascending, the program performs extra validation. It checks that the field name, the user type is valid, such as ID name, program, mark, or grade. It also verifies the sort order, ensuring it is either ascending or descending. If the user enters an invalid field or order, the program shows an error message and skips the operation. Once all validation passes, the program sorts the data if necessary and displays all records in a clear tabular format. For the delete operation, the program performs validation before removing any record. First, it checks whether the user actually typed something. Then it issues scanf to verify the input is a valid number. If the input is empty, contains letter, or isn't a valid ID, the delete operation is cancelled automatically. Only after the input passes validation does the program continue and delete the record with the specified ID. This protects the system from accidental deletions and ensures that only valid numeric IDs are processed. In conclusion, our system allows student records to be added, displayed, updated, deleted, and searched within a simple database. All data is stored in memory during runtime, and the user can also open existing files, save changes, and export records. A major focus of our implementation is validation. We check every piece of input the user provides, making sure it isn't empty, the right type, or outside valid ranges. This prevents invalid data from entering the database and ensures the program behaves predictably. We also use clear error messages and safe handling for mistakes, so the user always knows what went wrong and how to fix it. And that's the core of our system. Thank you.